that's we have connected our schematic completely, so that we have finished our circuits. So just we want to edit the schematic by giving the values. So resistor 1 R1, so the resistors are given. Once it is set, so leave it as it is. So this is the one which I am going to edit. Value here normal, it is given as a 1k, but for me I am going to use it as a 100 kilo ohm, 100 kilo ohm, and it is R1. As it is a simple circuit, I just don't need for any annotation, so that I can make sure that every component and the designators are set on final. This is, I am going to mention it as R3, and the value of it is 1k as usual, and this one is gonna be a R4, and the value of it is 1k. Okay, then this is the last resistor, which is gonna be a R2 is normal, and the value of it is 100k. That's it, and we're gonna get the value for capacitors. It is a C2 capacitor for my reference, and it should be of a just 20 microfarad. Okay, and this is the capacitor, that is a C1, which is the best. As usual, this is also 20 microfarad, and the value of the transistor is Q1, and for this is Q2. Yeah, we have done with it. So this is the one which I am going to use the designator as Y1 in some manner. So okay, we have to given it label for the supply and the ground, so that I am going to use that label here, here. This one should be a 12 volt, and this is the other one, which is the ground connection. Yeah, here we have completed our schematic. Okay, yeah, once we have completed the schematic, we are going to check the components which are attached with the 4 pins. So here's the 4 pin. The 4 pin should be a 2 pin header. This is the miscellaneous connector one. Miscellaneous connector, I need a header with the 2. Yeah, this is the one which I am going to use in it. Okay, and the resistors, in the resistor we have 4 pin already, which is the miscellaneous is 2 pin connector. Okay, the capacitors we have 4 pin, the transistor we have 4 pin. So just to wait, we are going to get a if we have a common footprint which we have made through the library, we can use it. So in order to verify the here's a kind of footprint. So we are going to use the footprint. This is the one which will be kept in this circuit, so we're going to use it. T092. Similarly, I am going to add for this also actually T092. Once if you know the name exactly, you can edit. So we can prefer the T092A. It's a better than T0. So I'm gonna change the previous transistor name. T092A. Okay. This is the footprint. So we have all done with the footprints added in the schematic. So once it is done, just save the schematic sheet, and we have to compile the project. So compile the PCB project. So to check get the messages. So compile successful, no errors found. So the circuit is fine and there is no error in. So then we can go for the project PCB. So here we are going to the new PCB. So the new PCB is set with it. So we can set up the grids. So we have to go for tools, grid managers, and we will get the grid manager dialog box, and then you can go for it. And I just wanna 10 mil set offset. So if you zoom in, zoom out, once you have zoom out, sooner the grids will be not displayed in the long view, so that you can set as a 5x script step. So for the first zoom, the grids will be visible. Then apply the changes. Okay, we can see that the grids are available here. Then click OK. Then click. So once it is done, save the project. Once the PCB is added into the project, save the project. So my project is a multi-vibrator. So multi-vibrator. Okay, it is done. Now I am going to update my schematics into this project. Update schematic. We can use update schematic, or else we can use input changes. Input changes actually we are in the initial stages. The schematic, once the schematic is updated, once the schematic is completed, if we are doing it in the second stages to update changes, we can prefer the update changes. Now we can go for import changes. So here are the engineering changeover dialog box, which displays the list of components and the nets connected and other rules and component classes specific. Give validate changes and execute changes. Now the status all done with it, and we have got the components here, which we can see here. Then close it. Once the project is complete, the components are being added here. Now we are starting with the placement. We have to set a design rules. So we have to go for design and rules, so that we can have a PCB rules and constraint editor, so that we can see and the list of rules which is already constantly fixed in the Altium designer. So in this we can specify separate clearance such as 10 mils, and it as a clearance, minimum clearance as equals in our project, or even 10 mil is not probably a big deal. Okay, sorry, design rules. The electrical checks we can have sub design rules, so we can see other rules as well. There we with the preferred with the certain the routing the width is specified as certain, so we can change it if we need it. Here we are going to add a new rule, so that we can name the rule as power width, so that the power mix is can. For this we are going to set advanced query builder, so it is built